So,
Okay.
good evening, everyone. This is the 10th session of Osdp. And today, once again, we have with us Dr. Vikram Atal sir from ICT Mumbai. So, I am very thankful to Vikram sir who spare valuable time with us because he's also busy in their academic work as well as in MTTS. So, once again, I am very thankful, sir. Now, please, you can share the screen
Yeah.
and start the session.
Okay. So, thank you once again for having me, for calling me back, Saeed sir. And it is my pleasure, of course, as always, to interact with you and now with your students as well. Uh, so, I just want to give a warning to the students today. Uh, so, let me just tell you a little bit of what I'm planning to do. Okay. And once I tell you that, then after that, I will tell you why I'm giving you a warning. So, see, what did we see last time? We discussed the definition of convergent sequences, and we saw that, okay, if we wanted to understand convergent sequences, the first question we could ask ourselves is we tried to find out some properties of convergent sequences, right? And we saw the one property that came out immediately just from the definition of convergence was that a convergent sequence is bounded. So we think of that as our first test of convergence. मतलब अगर हमको जानना है कि कोई सीक्वेंस कन्वर्जेंट है या नहीं तो सबसे पहले हम चेक करेंगे भाई बाउंडेड है या नहीं. If the sequence is not bounded, then we don't need to worry about it. It cannot be convergent, right? This contrapositive. So, but we also saw that this boundedness is not the ultimate test of convergence, right? So, can somebody tell me why it is not the ultimate test of convergence? That even if I find a bounded sequence, why can't I immediately conclude that the sequence is convergent? Yes, Arya? Aryan? Sahil?
Yes, sir.
Yes, now you're audible.
Yes, sir. Can I speak now?
Yeah, please.
Yes, sir. Yes, sir. We have found that there are some sequences which are bounded but not convergent, like taking xn is equal to -1 raised to the power n.
See, that is a better way of answering the question. Because if you say that there are some sequences, how do I know? Right? So whenever you're saying something is not true, a statement is not true, if possible, whenever possible, try to say that it is not true because we have this sequence xn equal to -1 to the power n. It is bounded, but it is not convergent. Yeah. So bypass that step of saying that there is some sequence. It's always better to give a very specific example. Okay? And this is a question of training. This is a question of habit. I think what Jai sir would have done in foundations and even Satya sir would have reinforced this idea that whenever we are answering questions, usually we tend to answer ki haan, may be true, may not be true, which is fine in a general conversation. अगर आप अपने दोस्त के साथ बैठ के बात कर रहे हो and if you're talking about whether RRR is a good movie or not, then yeah, this may be true, may not be true. That can be subjective. ठीक है, but जब आप mathematics की बात कर रहे हो, you have to sort of see, okay, if it is true, can I give a proof? If it is false, can I provide a counter example? So ये एक habit है which takes a little bit of time. मतलब मुझे काफी साल लगे ये आदत डालने के लिए. So try to get into this habit. Whenever you want to say that, okay, bounded does not imply convergence, okay, think of a bounded sequence which is not convergent. So say that, okay, bounded does not imply convergent because we have the sequence xn equals 1 minus 1 to the power n, which blah blah. Okay. Okay. So we saw that boundedness is a good first test, but what it mainly allows us to do, it mainly allows us to reject candidates. If we are looking for convergent sequences, it allows us to reject candidates. Okay. So we still So it's a good first test, but it doesn't tell us whether a sequence is convergent or not. And even if by some notion, when we find whether somebody tells us, somebody we trust tells us that, like, we all trust Sunil sir, right? So if Sunil sir says that this certain sequence is convergent, then we know that it is going to be true. It is going to be convergent. But if he doesn't tell us what the limit is, then whatever knowledge we have so far does not give us a way to compute the limit. So find out what the limit is going to be. Okay. Now, this in general is a difficult question to answer. But the plan I had for today is that rather than introducing you to more new topics, before we introduce new topics and new definitions, I thought what we could do is we could spend a little time taking some examples and actually seeing how to work with sequences, right? And along the way, what I want to present is some basic techniques which are used in analysis. These are some basic techniques, whether you study real analysis, complex analysis, numerical analysis, uh, ordinary differential equations, partial differential equations, these kind of techniques, these estimation techniques are going to be important. Right? Remember last time when I said that the most important question in analysis is what are we going to estimate, right? So I also want to say that all of this material you will find on Professor S. Kumarasan's YouTube channel. He has an entire lecture devoted to these, what I'm going to do today. Okay? So think of my lecture only as a brief introduction, a brief sort of a place where you can get some familiarity. Okay. And then I would highly encourage you to go and look at Kumarasan sir's video so that, you know, he's a master. So you will learn a lot of things from that. Okay. I have also learned from him. So I will try to do some justice to that. But that is the plan for today. We look at certain special sequences. We look at some special things. And along the way, we'll also get some properties. And if there is time, I will introduce a new concept. But the warning. The warning for today is that so I don't usually like to sort of say this, but as Sunil sir pointed out, that I am involved in a few other things as well. So this entire week has been a little busy. Today especially, I was outside all day. I just came back like half an hour ago. So I have not prepared at all for today's class. Okay. So I might make a lot of mistakes along the way. So the warning I want to give you is that I'm already telling you I have not prepared. I'm already telling you that there might be some mistakes and so on. So what I want you to do is to pay attention. Okay. And when I say mistakes, I don't mean कि अगर मैंने xn की जगह xk लिख दिया. That is not the kind of typographical mistakes. अगर conceptually कुछ mistake कर रहा हूँ, so keep an eye out for that. Okay. Like instead of greater than equal to, I'm writing less than equal to or something like that. Then, you know, point out those mistakes. Keep an eye out. And especially today, because I'm not prepared, what I want you to do is I'll try to walk you through my thinking process. So I want you to think along with me. Okay. Is everyone ready for that? I'm assuming everyone is ready. जवाब देने की जरूरत नहीं. Okay. So let me present my screen. Yes. Okay. So you guys can see my screen now, right? Okay. So we were looking at convergent sequences, and one of the important things that we had. So let me just recall the definition. So a sequence xn is convergent if, so you remember, there exists some x in R such that something happens. What is that something? You give me any epsilon positive, something should happen. What should happen? Given any epsilon positive, I should be able to find a stage. Okay. such that after that stage, what should happen? Mod of xn minus x should be. So after that stage, all terms of the sequence should be within an epsilon distance of my x. Yeah, and this x is usually what we denote as the limit of the sequences. Right? And the one property that we saw was that xn convergent implies xn is bounded, right? And we also saw that the converse is not true, right? By the way, if you want me to write a little bigger or something like that, please let me. Converse is not true because we take, as an example, we can take xn to be minus 1. Right? This is what we have done so far. Okay. Another important thing that I had mentioned in passing was that, say, suppose, and how do we write it? We say that, okay, say, suppose xn converges to x. We write it as in this way, right? Xn converges to x. So let's look at the sequence yn defined as xn minus x. This is a new sequence. What can you say about the sequence yn? If xn converges to x, then again, let's just plug that back into the definition. What we have is, if xn converges to x, I know that this is true. That means, what do I know? That means this mod of yn is less than epsilon, right? This mod of xn minus x is just mod of yn, which again I can think of as mod of yn minus 0, right? So just focus on this for every epsilon set. So xn converges to x implies the sequence yn converges to 0, right? Now again, what I have is xn converges to x se mere ko mila. Xn converges to x implies yn converges to 0. The minute I have something like this, what is the first thing I should ask? The minute I have an implication, first thing I should ask is, what is the natural question to ask? If I have P implies Q, then am I audible? Yes, Jyoti?
सर इसकी हाइपोथेसिस कौन है और कंक्लूजन कौन सा है?
नहीं ठीक है, वो तो हमको पता है. हाइपोथेसिस P है, हाइपोथेसिस है कि xn converges to x, कंक्लूजन है yn converges to 0. ठीक है, तो मैं पूछ रहा हूँ कि अगर मेरे पास एक ऐसा स्टेटमेंट है, एक इम्प्लीकेशन है P implies Q, और मेरे को पता है कि P implies Q ट्रू है, तो नेक्स्ट नेचुरल क्वेश्चन क्या पूछूंगा मैं अपने आप से?
Is its converse true?
Is its converse true? And what do you think? In this case, again, you can easily see, again, if I know that yn converges to 0, that means, okay, give me any epsilon positive, I can find n naught in n, such that for all n bigger than equal to n naught, mod of yn minus 0 is less than epsilon. But mod of yn minus 0 is nothing but xn minus x, right? So if I start with any epsilon positive, I know that there exists m naught in n such that mod of yn is 0 for all n bigger than equal to, which is nothing but xn minus x. So the converse is also true. So that means what we have is, we have that xn converges to x if and only if the sequence xn minus x converges to 0, which is not surprising, which is absolutely not surprising, right? If xn comes closer and closer to x, what can happen to xn minus x? That has to be closer and closer to 0, right? So this is a very natural thing. Okay. So now let's try to imagine something. So suppose I have a sequence xn and assume xn converges. Okay. So another important thing that we do in mathematics is that we keep asking ourselves, if I have one thing, suppose I have one function, okay, one important trick that you have to learn in all of mathematics is the trick of coming up with your own examples. Okay, how to construct examples on it, because that is going to help in two things. That is, A, it is going to help you answer a lot of questions. Okay, and B, it also helps you in understanding the basic ideas, understanding the definition. अगर आप अपने आप से example construct करो ना, and इसमें I'll tell you what, the mistake we all make is that we always try to come up with perfect examples, right? But don't worry about it. See, if I want to come up with examples of convergent sequences, I will try to sort of, how will I work with it? How will I go about it? Will I start with the thing that, okay, मेरे को convergent sequence ही ढूंढना है? नहीं. The way I would do it is that first I would think of 10 different examples of sequences, just sequences. And then for each sequence, I'll test the definition. Is it convergent or not? Along the way, I'll get some sequences are convergent, some are not convergent. Right? So that will give me an understanding of this definition of convergent sequences. The second way to do it is that, can I construct more examples from the examples that I already have? So suppose this xn is a sequence. Using this, can I construct a new sequence? Can somebody think of a new sequence just using xn? Is my question too vague? Yeah, I'm going to push yourselves a little bit, challenge yourselves a little. xn आपको दिया हुआ है, forget about convergence, forget about everything. मैंने आपको एक sequence दिया हुआ है xn. मैं बता नहीं रहा xn exactly है क्या, पर xn को यूज करके आप एक और एग्जांपल कंस्ट्रक्ट, एक और सीक्वेंस कंस्ट्रक्ट कर सकते हो. यस साहिल
सर xn minus n.
xn minus n, very good. Anything else? तो उसमें अभी आप क्या कर रहे हो कि आपके पास दो सीक्वेंसेस हैं, आपके पास एक xn सीक्वेंस है और एक n सीक्वेंस है, राइट? एंड यू आर कंबाइनिंग दोस टू इन एन अलजेब्रिक वे. या एनीथिंग एल्स? अगर मान लो मैंने आपको एक रियल नंबर दिया x एंड आई आस्क यू फॉर अनदर रियल नंबर, कैन यू थिंक ऑफ अनदर रियल नंबर? नेचुरल दिमाग में क्या आता है? यस आर्य?
So like previously we see that yn converges to 0. So can we say that xn plus y?
वो सब छोड़ो. सिंपल सवाल. I am giving you a number x. I have given you a real number. Now I am asking for a real number in return. Rohit?
So 2x.
Very good, 2x.
Yes, sir. Similarly हम xn की पावर n भी ले सकते हैं.
xn की पावर n भी ले सकते हैं, xn square भी ले सकते हैं, right?
Yes, sir.
So there are many different things I can use, I can construct, I can look at. So if I have this sequence xn, given any sequence xn, I can think of the sequence 2 times xn. This is a sequence. So suppose I've assumed that xn converges to x, what would your guess be about this 2 times xn? Do you think it's a convergent sequence? Yes, Sahil?
कन्वर्जेंट ही होगी.
लिमिट क्या होगा? कन्वर्जेंट क्यों होगा?
सर जैसे कि xn है तो इसका डबल ही बनेगा ना, जो भी हो.
नहीं तो लिमिट क्या होगा? अगर xn converges to x तो 2xn का लिमिट क्या होगा?
सर 2x
2x
2n
बस, और कुछ डबल कर रहे हैं ये कर रहे हैं वो बोलने की जरूरत नहीं। जितना इकोनॉमिकली हम समझा सके उतना अच्छा है, राइट? So 2x, yes, I agree that it converges to 2x. This have you seen, by the way? Was there anything special about 2? If I take, instead of 2, if I take any real number a and look at the sequence a times xn, sorry, these are the kind of mistakes you should do. 2xn converges to 2. If I take a times xn, then what will it converge to? A, right? So all of these things, I don't think you've seen yet in this particular course, right, Sunil sir?
Yes, sir.
So अभी तक आपने देखा नहीं है, but ये सारी चीजें आप देखो. Right? See, another thing I can do is that let's think about this. Now I can sort of make new sequences in many different ways. I can also look at, I can also look at the sequence xn square. Again, what would my guess be? Do you think xn square is convergent? Where do you think it's going to converge? X square? Is there anybody who disagrees? If you disagree, raise your hand. Who disagrees? Ankita, you disagree? आपको नहीं लगता xn square converge करेगा x square को? अंकिता?
Yes, sir.
हाँ, आपको नहीं लगता xn square x square को converge करेगा?
सर करेगा xn square x square को.
तो मैंने कहा अगर आप agree नहीं करते तो हाथ रेस.
Sorry, sir.
Yes, no problem. हाँ, so see, the thing is that, okay, as far as we're just constructing examples, now again, let's try to sort of imagine this, just intuitively, let's try to imagine, kya hota hai? Kya ho raha hai? Let's not worry about the details now. What I know is that, okay, as n keeps getting larger and larger, my xn's are all going to be, so my terms of the sequence are all going to be somewhere after a certain stage. They're going to be close, right? अब 2xn में मैं क्या कर रहा हूँ? 2xn में I'm just taking this, it's another thing. I'm just sort of enlarging everything, magnifying everything by a factor of 2. What do you think is going to happen? Again, all terms of the sequence 2xn are going to come close, ना? Because अगर इसको enlarge करके मैं यहाँ पे ला रहा हूँ, so if I take any neighborhood, okay, some enlargement of that is also going to be a neighborhood of 2x, right? So जो यहाँ पे blue dots यहाँ है, उसके doubles भी इसी के आसपास होंगे, correct? Now this is not the best way of explaining things, but it's just an idea. Do you get the idea at least? ये 2x वाले में थोड़ा simple है visualize कर. Get the idea? Raise hand if you get the idea. Why should 2xn converge to 2x? Just intuitively. Don't worry about like 100% मिला या नहीं, proof मिला या नहीं. Idea मिल गया ना तो बस. ठीक है? तो अब x square के लिए भी आप ऐसे visualize कर सकते. Okay? So that again, it's not as simple as visualizing for 2x. Okay, it's not as simple as that, but it's not very difficult either. Okay. And this you will see maybe next week or the week after that, you will see why this is true. Okay, but let's try to construct. Now I'm going to do something different. What I'll do is, instead of looking at this sequence xn and 2xn and so on and so forth, यहाँ पे भी आप देख सकते हो कि ये one thing you know is that, okay, if I take this, if I take any x, one thing I know is that what I'm doing here is I'm pushing it to this. X square is always going to be non-negative. So x square is always going to be on this part of it. Wherever my x is, x square is always going to be on this part, right? And again, what you can show is that, okay, if I take some neighborhood, the image of that also comes close to. So all terms, these xn squares are also going to be, they are not going to suddenly shoot out कहीं दूर जाके नहीं बैठेंगे, सब यही आसपास ही रहेंगे. वो अपनी ओरिजिनल जगह से ये नॉन नेगेटिव रियल नंबर्स के पार्ट पे आ जाएंगे, बट एवरीथिंग इज गोइंग टू बी क्लोज टू दिस x square. Okay. So with this idea, what I'm going to do now is I'm going to construct a new sequence. Right? Think of it this way, that what I've given you is that what is, if I give you a sequence xn, what am I giving you? For every natural number, I'm giving you a real number, right? For 1, I'm giving you the real number x1. For 2, I'm giving you the real number x2. 3, I'm giving you x3, dot, 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 so on. If I'm giving you xn, right? For n, I'm giving you xn. Now, suppose I give you n real numbers x1, x2, x3, xn. And suppose I ask for a new real number. मैंने आपको n numbers दिए हैं, and I want you to give me another real number. What is the most natural thing that comes to mind from this? Is Ashish?
अब क्लियर नहीं आ रही मेरे को.
हाँ,
वॉइस क्लियर नहीं आ रही आपकी मेरे को.
so voice clear नहीं है. मैंने पूछा कि मैंने आपको n रियल नंबर्स दिए, ठीक है, और एक्सचेंज में मैं आपसे एक और रियल नंबर चाहता हूँ, तो नेचुरल चीज क्या होगा? आप क्या करोगे? इन्हीं n नंबर्स का कॉम्बिनेशन बना के मेरे को कुछ दे सकते हो, राइट? क्या आर्यन, डिड यू?
Yes, sir. Like
मैक्स ले सकते हो, the
number.
biggest number you can give me, or I can just take the product of all of this,
Yeah.
or I
Yes.
can take the minimum, right? Or I can take the sum of all of this, or
Yes.
what I can also do is I can take the average of all, right? So
Yes, sir.
I can define a new sequence an. What is an? That is x1 plus x2 plus x3 and so on up to xn by n. This is the average mean of the first n terms. Yeah. So this gives me a new sequence, right? This an is a new sequence. Okay. Now, my assumption was that xn converges to x, right? And using this xn sequence, I've come up with a new sequence an. So what is a natural question I would like to ask about an? This is a new example of a sequence, right? जब भी मैं आपको कोई सीक्वेंस देता हूँ, yes, let me ask somebody else. Sahil, Aryan are always raising hands. Let me ask somebody who has not. See, Rimanshi. Rimanshi. Okay, Vanshita. Sakshi,
Yes, sir.
तो आप an के बारे में क्या पूछना चाहोगे? What is a natural question? I know xn converges to x. An is the average sequence.
an किस पे कन्वर्ज कर रहा है?
पहली चीज an convergent है या नहीं, right? An convergent है. Okay. So let's try to sort of understand this a little bit. Let's just get the idea a little. Okay. Now suppose, again, let's think of it in terms of pictures. So suppose I've given you some n numbers, x1, x2, say, x3, x4. Where will I draw? If I want to draw A4 now, if I want to draw the average of this, where do you think I'm going to draw it? Do you think I'll draw the average here? Do you think I'll draw the average far away over here? मेरे दिमाग में जब मैं average सोचता हूँ, where will I think of it? How many of you agree, or how many of you are feeling that the average should be something like where I've drawn the pink dot? Raise your hand if you think that the pink dot seems like a reasonable picture for a reasonable place for the average. Okay. अभी यहाँ पे काफी physics, chemistry के majors हैं, तो I mean, this is like the center of mass, no? The average value is going to be somewhere in between, in the middle, right? So it's not going to go far away from the values that I have. It's going to be somewhere in the middle. In fact, you can see that if I take more terms, so suppose if my x5 is here, x6 is here, x7 is here, x8 is here, then now this seems even more believable, right? Yeah. So now think about it. So I have this x and I know my xn converges to x, right? I know my xn converges to x. So what do you think is going to happen? So suppose my x1 is somewhere here. This is not an accurate picture. x2 is here. And dot, dot, dot. I mean, say this is x10. As n keeps getting larger and larger, I keep coming closer and closer. So x1, x2 का अगर मैं average बनाऊं तो कहाँ बनाऊंगा? Let's stick to the pink dots. It's going to be here, right? x1, x2, x3 का average बनाऊं तो it's going to again be a little closer. x1, x2, x10 का average बनाओ तो it's going to be somewhere over. x1 to xn का average बनाओ तो it's going to keep shifting, right? So what do you think happens as n keeps getting closer and closer? What do you think is going to happen to this average? Yes, Vivek?
Yes, sir.
Let's make a guess. क्या होगा average का?
सर एवरेज भी जो वो एक्स की तरफ जा रहा है, मतलब एवरेज बढ़ता जा रहा है
इसकी
उनमें।
तरफ जा रहा है, right? बढ़ता मतलब एटलीस्ट जिस तरह मैंने पिक्चर बनाया उसमें ऐसे लगा, right?
Yes, sir.
प्रियांश, आप सहमत हो इस बात से? प्रियांश?
Yes, sir. Yes, sir.
Yes. Okay. So what we guess is that now we just have a guess based on our intuition. We've made a guess that. So we've made a guess. Let's write it down. So we've made a guess that an converges to x. Right? This is our guess. In fact, we are a little more confident, so we can get rid of this and we can say that this is actually our claim, because we are confident, right? So now how do we prove this? How do we prove this claim? See, the first thing you should note is that, okay, let's look at, so if I want to show an converges to x, that is the same thing as showing an minus x converges to 0, right? So you look at this sequence an minus x. Let's write it out. So this is x1 plus xn by n. So an minus x is just this, right? Minus x. So I can think of this as xn by x minus by n minus n times x by n, right? Which is again nothing but I can take this fellow in now and I can distribute it. So what I get is x1 minus x plus so on up to xn minus x upon n. But what do I know? I know that xn converges to x. This happens if and only if xn minus x converges to 0, right? So over here, this is when I look at an minus x, that is the same as the average. So let me make this statement. This an minus x is the average of x1 minus x and so on up to xn minus x, right? Yeah. So I already know that this sequence converges to 0 and I want to show this sequence converges to 0. So what I can do is I can make a reduction. So if I show the following, so let's make the following reduction or simplification. If I assume xn converges to 0, okay, using this, if we can show that this an converges to 0. Remember, this an is my average always, right? If we can show this, from this we can also show the general, right? Yeah, does everyone agree with this? Yeah, if you agree, raise your hand. मतलब अगर मैंने xn conversion to 0 के average को भी दिखा दिया that the average goes to 0, then the general case can be done, because वो an minus x का average is precisely xn minus x का average, right? An minus x, sorry, is precisely xn minus x का average, right? So this is another important thing in mathematics, that we always try to reduce it to simpler case where our life becomes a little easier, computations become easier. Okay, right. Okay, so since everybody agrees with this, so the next thing is, so now we are only going to work with the assumption that, so now we are in the case, so now what we want to show is that xn converges to 0 implies this an, which is 1 by n times this converges, right? This is what we want to show. Great. Okay, so now what we know is, let's just write down what we know is xn converges to 0. Okay. And to show that an converges to 0, what do we need to estimate? If I want to show an converges to 0, what do we need to estimate? Who raised their hand? Okay. Yes, Aryan or Rohit, maybe. Yeah, Rohit.
सर लिमिट
कौन सा लिमिट? नहीं, हमको कुछ एस्टिमेट करना है ना.
Yes, sir.
तो क्या एस्टिमेट करना?
Mod of
साहिल,
xn minus 0 is less than epsilon. an
हमको
an के लिए
an के लिए करना है, राइट? तो
yes,
हमको
mod of
दिखाना है
an
कि
minus 0.
mod of an minus 0 तो मतलब mod of an, राइट?
Yes, sir.
So we need to estimate mod of an. So we need to estimate, very good. We need to estimate mod of an. So let's try to see what we get. What do we know about mod of an? Mod of an is nothing but right. What does this give us? Simplest thing that I can do now, simplest thing that I can do is I can say this is less than equal to mod of x1 plus mod of xn upon n. How did I get this inequality? What is the thing that I used? Yes. So I can't see both the place where I'm writing and the Google screen. So
Vivek,
yeah, Vivek.
Yes, sir. Sir, triangular inequality से.
So ये triangle inequality, right? This is just simple triangle. So triangle inequality, जैसे मैंने कहा था, it's going to be very important because this is what is going to give you the first estimate. Okay. So the triangle inequality is something that tells us that okay, mod of an I can estimate in terms of this mod of x1 plus so on by n. But अब क्या करें? आगे जाके क्या करें? So if I want to, what do I say that I want to estimate? What does that mean? That means what I really want to do is, okay, so given some epsilon positive, given any epsilon positive, I want to show that there is a stage after which mod of an is less than equal to 0, right? So let epsilon positive be given. Okay. I don't know what it is. I need to sort of find a stage. So we need to find some n naught in n such that for all n bigger than equal to n naught, what happens? Mod of an is less than epsilon, right? I need to find this. Right now, I don't know anything. Okay? But what do I know? What I know is that I know my xn converges to 0. My xn converges to 0, right? What does that mean? Yes, somebody have a question?
no, sir, no.
Oh, okay. So because my xn converges to 0, what does that mean? That means for this epsilon positive, I know that there exists some n1 in n such that for all n bigger than equal to n1, mod of xn is less than epsilon, right? तो अभी यहाँ देख लो, अभी मैंने देखा है कि for mod an, I know that mod an I can write as this mod of x1 blah 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 mod of xn by n, right? So suppose I start with some n which is bigger than n. Then what I can do is this mod of an, I can think of, I know that this is less than equal to mod of x1 plus mod of xn1 minus 1 plus mod of xn1 and so on up to mod of x. Whole thing upon it. Yeah, this whole thing upon it. Now what do I know? I know that okay, so let's just write it. So that means now I can think of this mod of an as अब ऐसे मौके में ना we'll do a trick which is called the divide and conquer trick. See, what I know is that these fellows, ये जो x1 to xn minus 1 ये जो बंदे हैं इन पे मेरा कोई कंट्रोल नहीं है. ये जैसे मैंने पिछली बार कहा था, ये वो बदमाश बच्चे जो शहर में भटक रहे हैं, ना लेक्चर अटेंड कर रहे हैं ना टाइम पे आ रहे हैं, राइट? I don't know how to control them, but what I do know is I know how to control these guys. these are all good kids. They are all well behaved. So I know that each one of these fellows I can control. I know that these fellows I can make less than epsilon. Right? Yeah. So what I'll do is this average, I'll divide it into two parts. I'll divide it into the people I know I can control, and then I'll see जो ये x1 to xn minus 1 है, इनके साथ कैसे इनको कैसे पकड़ना है मैं बाद में देखूं, right? So I will apply or I will use a divide and conquer. Right? So I've divided my estimate into these two parts. So now I know that okay, I need to estimate this part and then I need to estimate this part. But what does this tell me? This tells me that okay, how many elements here? कितने हैं यहाँ पे? Sum में. Let's just focus on this a little bit. यहाँ ऊपर मेरे को पता है that each one of these individual fellows is less than epsilon, right? Each one of these individual fellows is less than epsilon. कितने terms हैं यहाँ पे इस sum में? कितने terms हैं? xn plus 1 से लेके xn. Yes, Aryan?
Sir, there are, I think, n minus n1 terms.
N minus n1 terms, right? Yeah.
Yes, sir.
So what I can say is that each one of these guys is less than epsilon, and there are n minus n1 terms. So this is n minus n1 by n times epsilon. Does everybody see this? This xn1 is less than epsilon, xn is less than epsilon. So each one of these guys is less than epsilon. So this is n minus n1, which is less than epsilon. Right? Yeah. But now let's look at this. What was my assumption? My assumption was n was strictly bigger than n1. So what can you say about n minus n1 and n? इन दोनों में कौन बड़ा है? Yes, Priyansh. Rohit.
Yes, sir. Yes, sir.
Yes, whoever is saying. Yeah, Priyansh, go ahead. N is bigger, right? N minus n1 is strictly less than n, right?
Yes, sir.
So n minus n1 is strictly less than n. So what can you say about n minus n1 by n? That is less than 1. So that means this fellow is less than epsilon, right? So this is what I mean by divide and conquer. So now what I have is that now I have that this mod of an. So again, this n is bigger than n1. Mod of an is less than mod of x1 plus mod of n1 minus 1. This whole thing upon n plus epsilon. Right? So I'm almost there, but मैं पूरी तरह पहुंचा नहीं हूं because इनका क्या करूं मेरे को नहीं पता. Right? इनका क्या करूं मेरे को नहीं पता. I would like this entire thing to be less than something like less than epsilon. और अभी मेरे को सिर्फ एक पार्ट मिला है, epsilon plus something. Right? And again, even note that how did we get this n1? This n1 depends on this epsilon, right? As epsilon changes, this n1 changes. So there is no uniform estimate that I can get for this. Yeah. So I need to find a different way of controlling this. So now what do I do? How do I deal with? So another question is, how do we deal with this mod of x1 plus, or say, mod of xn, right? How do we deal with this? But now let's recall. So let's remind ourselves that हमारा assumption क्या था? हमारा assumption था that xn converges to 0, right? That is, this xn is convergent. Okay. So the minute I know that xn is convergent, what is the first thing I can conclude? Remember that it passes our first test, right? So what does this imply? This implies xn is bounded, right? That is, I know that there exists some positive real number m such that for all natural numbers, mod of xn is less than equal to, right? So ये मेरे को पता है, this is true for all n. So in particular, even for these, so in particular, what I have is, so this mod of x1 is going to be less than equal to m, mod of x2 is going to be less than equal to m, and mod of xn minus 1, this is also going to be less than equal to m, right? Yeah. So now let's plug this back in. What does that tell me? So now let's look at this mod of x1 plus mod of x1 by n. What do I know? Each one of these individual terms is less than equal to m. How many terms are there? n1 minus 1 terms are there, right? So this is less than equal to n1 minus 1 by n times m. Yeah. This is less than equal to n1 minus 1 by n times m. So what do we finally have? We have mod of an. Now I can say this is less than equal to n1 minus 1 by n times m plus epsilon, right? Correct? Am I done? Am I done? Now see, now there is a problem. यहाँ पे ये बंदा फिर भी मेरे को problem create कर रहा है, right? Now suppose I can show, so if I can make this less than epsilon, then at least what I'll have is I'll have mod of an is less than equal to less than 2 epsilon, right? At least. So can I make, so now the next question I can ask myself is that, can we make this n1 minus 1 by n times m less than epsilon? Now again, what does it mean to say can we make it? यहाँ पे dummy variable क्या है? ये n है, denominator. That is, we can refine our question a little bit. Can we find some natural number n such that n1 minus n by n is times m is less than epsilon? In fact, let's say, I'll tell you that. Do you think I can find a natural number like this? Yes. Who raised their hand? Rohit?
Rohit,
Sir, 1.
1 क्यों?
ओके सर, पर्टिकुलर n2 के लिए.
अच्छा, n, अगर वो n2 आप कंफ्यूज कर रहा ना तो वो हटा दो, मैं पूछ रहा हूँ कि let's forget about 2. Can I find a natural number n such that this is true? अब मेरे को नहीं पता m क्या है, मेरे को नहीं पता n1 क्या है, और मेरे को नहीं पता epsilon क्या है. Especially epsilon, I have no idea, right? Because epsilon is something that is given to me. Yes, Aryan?
Yes, sir, not sure about the exact answer, but I think there is something to do with the Archimedean property.
साहिल, आप क्या कहना चाह रहे थे?
सर आर्किमिडियन प्रॉपर्टी से बन जाएगा।
आर्किमिडियन प्रॉपर्टी से बन जाएगा ना, जब भी हम कोई नेचुरल नंबर ढूंढ रहे हैं, स्पेशली विच सैटिस्फाइज सम इनइक्वालिटी। सी, if I just change it in a slightly different way, that is, can we find n in n such that, अभी मैं n को एक जगह ले जाता हूँ, एप्सिलॉन पॉजिटिव है, such that this n1 minus a times m by epsilon is, can I find an n which is bigger than this real number? And the answer is yes, by Archimedean property. Right? Now, Archimedean property implies there exists some natural number n2 in n such that this n1 minus 1 times m by epsilon is strictly less than n2. Right? That is, this n1 minus 1 by n2 times m is less than epsilon. Now, so what I now have is that this mod of an, this is going to be, so if I take my, abhi see, think about it, मैंने क्या किया, मैंने पहले तो ये इसको स्प्लिट किया दो पार्ट्स, राइट? ये दो पार्ट्स में स्प्लिट करने के लिए मैंने कौन सा n चूज किया? आर्बिट्री n नहीं था ना, मैंने इसके लिए चूज किया था n बिगर देन इक्वल टू n1। ठीक है, n बिगर देन इक्वल टू n1 करके मैंने इसको स्प्लिट किया, and then this part I could show was less than epsilon. Now suppose if I take some n which is also bigger than n2, then what can you say about this n1 minus n times m? This is less than n1 minus 1 by n2 times m, right? Which is less than epsilon. So if you give me any n bigger than n2, then even this part is going to be less than epsilon. Correct? So if I want to estimate for which n can I estimate, if my n is bigger than n1 and my n should also be bigger than n2, right? So now what will I do? Suppose I take n naught. Yes, Vivek?
Vivek, please raise the hand. Vivek, any
Yeah, Vivek?
questions?
नो सर।
हाँ, क्या कह रहे थे आप? See, if I take n naught to be maximum of n1 and n2, and suppose I know that if I take any n bigger than equal to n naught, then what do I know? This implies n is bigger than equal to n1 and n is bigger than equal to n2. So what can I say about mod of an? Mod of an, I know that, see, this is going to be less than equal to mod of x1 plus mod of xn1, right? n1 जहां भी आए, अब मेरे को पता है कि या तो n naught यहाँ, या तो xn naught यहाँ होगा या xn naught इसके आगे होगा, right? So it doesn't matter, but in any case what I know is that I can split this sum. Right? And what we have seen is this fellow I've made it less than epsilon. Okay. In fact, I can just take n naught here. This fellow I made it less than epsilon, and this fellow I know is n naught minus 1 by n times m. Okay. Which I already know this fellow is also less than epsilon. Right? So this is less than 2 epsilon. Okay. Take 20 seconds, think about this. If there are any questions, please ask. If at least 40% of the idea is clear, please raise your hand. Right? So what I've got now is, so I started with an epsilon positive, which I didn't know. And what I found is, we found some n naught in n, such that what happens? You give me any n bigger than equal to n naught, mod of an is less than 2h. But am I done? मेरे को चाहिए था it should be less than epsilon, right? Yes? Sahil?
Yes, sir.
तो मैं less than epsilon कैसे करूं? Less than epsilon कैसे करूं?
सर जहाँ पर एप्सिलॉन चूज किया था उसको एप्सिलॉन बाय 2 चूज कर लेंगे.
Epsilon by 2 हम choose नहीं कर रहे. The small thing I want you to understand. So what I'll do is I'll do the following. So if the idea is clear, let me try to show you कि textbook में कैसे लिखेंगे. अब मेरा यहाँ पे क्या है, ये 2 एप्सिलॉन क्यों आ रहा है? क्योंकि यहाँ पे मैंने इस बंदे को लेस देन एप्सिलॉन दिखाया, इस बंदे को लेस देन एप्सिलॉन दिखाया. So what I can do is I can go back and instead of epsilon, everywhere I can take this to be less than epsilon by 2. Right? I can ask for all of this to be less than epsilon by 2. Right? तो यहाँ पे 2 आ जाएगा. Right? यहाँ पे 2 आ जाएगा. And यहाँ पे भी मैं epsilon by 2 लेता हूँ. Yeah. So once epsilon is given, because I know that xn is a convergent sequence, that xn converges to 0. Given epsilon positive, I can find some n1 such that this mod of xn is less than epsilon by 2. So now, if I want to write a textbook proof, so this was the idea. Now, do you appreciate how we actually got this n naught? So if I want to write a textbook proof, what I will do is I will say that, okay, let epsilon positive be given. Okay. Then I will say that since xn converges to 0, I have two things. First, what I get is that there exists some m bigger than 0 such that for all n in n, mod of xn is less than equal to 1. Right? That is, this means that the sequence is bounded. Okay. And the second thing I get is there exists some n1 in n such that for all n bigger than equal to n1, mod of xn is less than epsilon by 2. Okay. अब मैं बताऊंगा नहीं आपको मैंने ये epsilon by 2 क्यों लिया. And then I will say that, okay, randomly, what I will say is that, okay, by Archimedean property, there exists some n2 in n such that for all n bigger than equal to n2, what do I get? This n1 minus 1 by n times m, this is less than epsilon. Right? So if I want to write a textbook proof, I will not tell you anything about this n1 and n2. ये कैसे मिला मैं बताऊंगा नहीं, मैं सिर्फ ये directly लिख दूँ. But now you understand why we actually chose this n2 like this. Yeah. And now what I'll do is I'll just go to mod of an. So mod of an I will write as mod of x1 plus xn. No, sorry. One more step before this. And I will say let n naught be maximum of n1 and n. Okay. So let n naught be the maximum of n1 and n. So given any n, so given any n bigger than equal to n naught, what I have is what happens to mod of this an. Write this as xn naught plus xn naught minus 1 plus xn naught plus xn, this whole thing by n. And by triangle inequality, what will I have? By triangle inequality, this is less than equal to mod of, let me just write triangle inequality here only. So that n naught, right? And I know that each of these guys is less than epsilon. So I know we've already seen that this is going to be less than epsilon by 2, right? And this is n naught minus 1 by n times m plus this, which I know is less than epsilon by 2. Right? So this is how I will write a textbook. But now, do you appreciate how important the divide and conquer trick is? Again, I think before we proceed, take 10 seconds, think about it. If you have understood, please raise your. Actually, this is the trouble with Google Meet. In Zoom, I can ask you to say yes, and if you have a question, then raise hand. यहाँ पे दोनों के लिए I will ask you to. So, okay, first, if you've understood this proof, then please raise your hand. And when I say understood, I'm not asking for like 100% understanding. 50% if you've understood, please raise your hand. Yeah, it's nice. This is the crux of analysis. This is how you do estimates. Okay, this is how you do estimates. So what we have shown finally is we have shown. So let's consolidate. What we have shown is that if xn converges to 0, then this average sequence, this converges to 0, right? And as a corollary, what we can show is if xn converges to x, then this an, which is again the average, this. Yeah. So we've given a proof of this. Yes. So now you see, we didn't need to use any techniques, anything. We just used some basic analysis. We just used some very basic analysis to conclude this result. Okay. So do you want to see some more estimates? So do you want to see some more sequences and estimates? Let me check if anybody has raised their hands. At least one person has raised, 2 people have raised their hands. So I'll go ahead with that. So the idea is I want to sort of show you how to use this, and the sequences that I'm going to consider are, there are many different ways in which you can prove this. Okay. So suppose I have some real number r between 0 and 1. And I define xn to be r to the power n. What can you say about this xn? Is it a convergent sequence? Yes.
Yes, Sahil.
यस सर कन्वर्जेंट होगी
Limit क्या होगा?
सर जीरो की तरफ अप्रोच करेगा ये।
0 की तरफ जा रहा है. Because if r is less than 1, then you know r square is less than r cube is less than r square, right? So इस sequence को convergent prove करने के लिए बहुत सारे तरीके हैं. आप ये भी दिखा सकते हो कि this is a monotonically decreasing sequence which is bounded below. This will, if it is not done, it will be done. It's a monotonically decreasing sequence which is bounded below, and therefore it converges. It's convergent, and you can compute the limit using algebra of sequences and so on. But what I'm going to show you is I'm going to show you a slightly different way of showing this, that this is convergent. Okay. So let's try to see how to actually how to work with this sequence. And I'll give you another example where this actually comes out very nicely. So you look at this r is less than 1. Right? So what can you say about 1 by r? This is 0, this is 1. If I draw my r over here, where will I draw 1 by r? 1 by r is going to be bigger than 1, right? Yeah. So this 1 by r, I can think of, this is strictly bigger than 1. So I can think of this as r plus some h, right? Where h is some positive real number. So I can write this 1 by r as 1 plus h. And I'll tell you why I am doing all of this. So what happens? So what happens to then 1 upon r raised to power n? This is nothing but 1 by r the whole power n, which is nothing but 1 plus h to the power n. Correct? Yeah. Okay. Now let's look at this 1 plus h to the power n. The minute I give you something like a plus b to the power n, आपके दिमाग में सबसे पहली चीज क्या आती है? Maybe let me ask Sahil, even though he didn't raise his
यस
hand.
सर
अगर मैंने ये ऐसा एक्सप्रेशन दे दिया तो आपके दिमाग में पहली चीज क्या आती है?
सर ए प्लस बी का स्क्वायर
a plus, if अगर मैं a plus b स्क्वायर दूं तो आप क्या बोलोगे मेरे को तुरंत? आर्यन?
Yes, sir. So binomial theorem.
बायनोमियल थ्योरम. आप एक्सपांड करना चाहोगे, राइट?
Yes, sir.
A plus b square, if I give you a plus b the whole square, you'll say, okay, that's just a square plus 2ab plus b square, right? So what is the expansion of this fellow? By binomial theorem, what do I get? If I expand it, what do I get? This is just 1 plus n choose 1 1 times h plus, and what is this? N choose 1. Okay, let me write. Plus, what is the general term going to be? N choose k, 1 to the power n minus k, h to the power k, plus so on up to h to the power n. Right? Let me just modify it a little bit. This is 1 plus n times h. N choose 1 is just this, right? Plus something something, plus this h to the power. Right? Now you see, look at all of this. this is bigger than 0. Each one of these individual sums is bigger than 0. So this whole thing I can write as something plus nh, right? Where this is a positive real number, right? So what does that mean? That means if I compare this number 1 plus h raised to n and this number nh, which one is bigger? 1 plus h is bigger, right? So this is bigger than equal to n times h, right? So now what do I have? That is, let's see, 1 upon r raised to n, which is 1 plus h to the power n. This is bigger than equal to n times h. That is, this 1 upon r raised to n, this is bigger than equal to n times h. So what can you say about r raised to n? We have 0 is less than equal to r to the power n. If r raised to n is bigger than equal to nh, this implies 1 by nh is, sorry, 1 by nh is bigger than equal to r to the power n, right? That means I get this is less than equal to 1 upon n times h, where h was just positive. And this is true for all n. So now what have I shown you? I've shown you my xn was just r to the power n. My xn was just r to the power n. And what I've shown you is that this xn is less than equal to 1 by nh for all natural. So what do you think is going to happen? As n keeps getting larger and larger, what happens to this fellow? What happens to 1 upon nh as n keeps getting larger and larger? Yes?
Yes, Preeti. Preeti.
Sir.
Yes? Yes, Preeti?
Ashish.
Ashish?
शॉर्ट होता जाए
हाँ?
सही जीरो की तरफ
0 की तरफ जा रहा है, right? As n keeps getting larger and larger, ये तो वही का वही रहेगा और ये 0 की तरफ आ रहा है. तो इसका क्या होगा? xn को क्या होगा? ये भी 0 की तरफ आएगा, right? This is what you call सुनील सर, इन लोगों ने सैंडविच लेमा देखा है क्या?
Sir, most of the students, because in second year, they've gone through this sandwich lemma, even in differential calculus also.
ठीक है. So can I assume sandwich lemma, or do you want me to prove it or something? How many of you are comfortable with sandwich lemma, sandwich theorem? Raise your hand. Okay, not too many people, unfortunately.
Sir, Sangeet sir will discuss in the next session.
Okay, so sandwich lemma is something that Sangeet sir is going to discuss. So basically, just roughly think about this picture, that ये जो sequence 1 upon nh है, ये मतलब अभी ऐसे इमेजिन करो कि आप कोई एक भीड़ वाले ट्रेन में हो, ठीक है, आप या बस में हो और आपके आसपास जो लोग खड़े हैं उनको एक स्टॉप पे उतरना, आपके आगे वाले को स्टॉप पे उतरना, आपके पीछे वाले को स्टॉप पे उतरना. आपका क्या असर होगा उसमें? आपको भी झक मार के उसी स्टॉप पे उतरना होगा. आगे वाला वहीं जा रहा है, पीछे वाला वहीं जा रहा है, तो आपको साथ में ले जाएंगे, राइट? So that is the basic idea of the sandwich lemma. Okay. So over here, yes, Ashish, कोई सवाल पूछना था?
No, sir.
Okay. So over here, what we have finally is that this implies, so by sandwich lemma, which you will see, coming soon. Sandwich lemma implies xn converges. That is r to the power n converges. Okay. Let me give, I have 7 minutes left. I want to give another application of this. Like, okay, what is the advantage of using this method? Let me quickly tell you that the advantage is, now let me consider a sequence xn equals n times, again, let's fix 0 less than r less than 1, and let's take xn to be n times r to the power n. Now again, it's not easy to sort of see what happens to xn. I mean, r to the power n is going to 0, but as n keeps getting larger and larger, this ye factor thoda bada hota ja raha hai, right? So I can't guarantee what happens to xn, right? I don't know what happens to xn. Okay, so how do I actually work with this? Now again, let's try to do the same trick. So let's take 1 by r equals 1 plus h. So 1 by r to the power n, again, the same is 1 plus h to the power. In this binomial expansion, 1 by h to the power n, हमारे पास क्या था? ये 1 plus nh plus ये n choose 2, which is n into n minus 1 by 2 times h square plus something plus h to the power. Right? Abhi all of these guys, h ye sab constant terms, so they are not going to matter. So I can say that this is bigger than equal to n into n minus 1 by 2 times h square for all n. Right? So in particular, what I can say is that if n is sort of strictly bigger than 1, what I can say now, why do I need to take n bigger than 1? Because n minus 1 term. So this 1 upon, so Rn, which is equal to 1 upon 1 plus h to the power n, this is less than equal to 2 times 2 upon n into n minus 1 times h square, right? So this implies n into r to the power n, this is less than equal to n into 2 upon which is just this 2 by h square is just a constant, it doesn't matter. The important thing is, and this is of course bigger than equal to 0. So again, you see what happens. This 0 remains as it is. As n keeps getting larger and larger, what happens to this guy? This goes to 0, right? ये तो constant term है, इसको मैं constant लिख सकता हूँ. The sequence 1 upon n minus 1, this goes to 0 as n keeps getting larger and larger. So by the sandwich lemma, again, this fellow will also go to 0. That is, the way you would have written it is this limit n into r to the power n, this is equal to 0. Yeah. Is that okay? Is this okay? Yeah. People already डर गए. People are leaving the meeting already. Is this idea clear? So as an exercise, what I want you to do is, as an exercise, try and don't worry about succeeding or failing. Look at the sequence. Think of convergence of xn equal to, again, r is between 0 and 1. Now I take n square r to the power. What happens to this? How would you actually use the same idea? What kind of an estimate will you? Sunil sir, can I take 2 minutes?
Yes, sir. It's already
I just
6:28. You have 2 minutes more, sir.
Because I just want to give one more example.
Yes, sir. You can.
Let's take one more example. Let's take a bigger than 0. And let's take xn to be nth root of a. That is a raised to 1 by n. What do you think happens to this sequence? Do you think this is going to go to do you think this is going to go to 0? What is going to be the limit of this limit?
Yes, Sahil.
सर 1 को करेगा अप्रोच
1 तो करेगा. प्रूफ कर सकते हो?
सर जैसे n बढ़ेगा तो 1 बाय n जो वो 0 को अप्रोच करेगा तो a की पावर 0 जो हो जाएगा.
ये गलत है. ये प्रूफ थोड़ी है. ये किसने कहा कि if I take something like a to the power some xn, किसने कहा if xn converges to 0 then implies a की power xn converges to 1? ये कैसे प्रूव करें? Let's try to think. Okay, let's take two cases. Okay, let's take case 1. Suppose my a is bigger than. What does this imply? That means my a to the power 1 by n is also going to be bigger than 1. Right? So I can think of this a to the power 1 by n as some 1 plus hn. Right? Where hn is positive for all. So what does that mean? That means now my a is 1 plus hn to the power n. Right? Which is bigger than equal to n times hn. And of course, this is bigger than equal to 0. Right? So what I have is a is, let me write it again, 1 plus hn to the power n, which is bigger than equal to n times hn, which is bigger than equal to 0. Right? So what does this imply? This implies, so now see, my n times hn is less than equal to a. Right? This implies 0 is less than equal to hn is less than equal to a by n. Abhi a mera constant hai, right? Again, 0 remains where he is. As n keeps getting larger and larger, what happens to this a by n? That goes to 0, right? So what happens to hn by sandwich lemma? Hn also goes to 0. Right? So that means my hn goes to 0. And what is a to the power 1 by n? This is nothing but 1 plus hn. So this implies as n goes to infinity, this goes to 1 because hn goes to 0. Right? Again, I mean, this will only be clear if you think about it a little bit. So I'll just end with case 2. Case 2 is very simple. What happens if 0 less than a less than 1? Then you take b equal to 1 by a. Then I know that b raised to 1 by n is 1 upon a raised to 1 by n. And we know that b is bigger than 1. So we know that b to the power 1 by n goes to 1. So this will imply a to the power 1 by n. Okay. So okay, I think this is something that you will need to sort of work out on your own. But I hope the idea is clear. I just wanted to give you an idea of how to get these estimates. Okay, these are some important tricks that you use in analysis. These are some very nice and very important tricks that you use in analysis. Okay. The similar trick a to the power 1 by n के लिए जो हमने trick use किया, ये same trick use करके आप n raised to 1 by n को भी दिखा सकते हो. That converges to 1. But what I would recommend is that just today, for today's lecture, when you go through it, when you review it, discuss the important tricks more than the actual answers. More than the answers, focus on how we got the estimates. Okay, estimate निकालने के लिए हम लोग ने inequalities के साथ हम कैसे खेल रहे थे? How did we use those inequalities? How did we use those estimates? And again, in the group discussion, you can actually in group discussions, you can actually try to sort of work out that n square r to the power n exam. उसके लिए हम कैसा estimate करें? And another important trick we learned today is that average sequence के लिए that divide and conquer trick. So see exactly how we divided that sum into two parts. One part was जहाँ पे हमारे पास कोई control नहीं था, एक part was where we had control. So the first thing we did was जहाँ पे हमारे पास control था, उसका हमने एक estimate निकाल दिया. And then we worried about, okay, how did we look at the other part of this? Okay. So I think I'll stop here. If there are any questions, please ask.